All right, today we're going to tackle a real powerhouse in the Java world, Jakarta EE. Now, you might have heard of it. It's the go-to standard for building these massive, scalable enterprise applications. But let's be honest, it can seem a little intimidating. So we're going to cut through all that noise and really see what makes it tick.
So let's just jump right in. Picture this. You've got a simple little script, right? Maybe it automates a tiny task for you. Now, imagine the complete opposite, an application for a huge airline or a major bank. How do you possibly handle thousands of people all trying to book a ticket or transfer money at the exact same time? How do you guarantee everything is secure and that every single transaction completes perfectly or fails safely?
Well, the answer is you need a lot more than just your own code. You need a standardized, super robust framework. And that, my friends, is exactly what Jakarta EE is. It's not just another library you pull in, it's a whole platform. The core idea is this thing called a container, which you can think of as this incredibly smart runtime environment that does all the heavy lifting for you.
Okay, so to really wrap our heads around this, we're going to follow a single request on its journey through a slice of a Jakarta EE application. But first, let's kind of set the stage and look at the exact challenges it was built to solve.
And this really highlights the jump-in complexity, doesn't it? On one hand, you've got your simple app, maybe one person using it at a time. But on the other, you're talking about an enterprise app that has to juggle thousands of users all at once. You're moving from just basic logic to incredibly complex business rules, and from simple data storage to needing absolute rock-solid data integrity with things like transactions. Jakarta EE is what provides that managed infrastructure to handle all of this for you.
All right, let's start that journey. A user just hit enter in their browser. That request is flying across the internet towards our application. So what happens first? How does it even get in the front door and into our code?
And that's our first big problem, right? How do we even create an entry point for these interactions? We need something that can listen for web requests at very specific URLs, like an API endpoint, and then know exactly which piece of our Java code to hand that request off to.
So, in the Jakarta EE world, the answer is Jakarta REST, also known as JXRS. It's an API specifically designed to make building these web entry points incredibly simple. It works by using these things called annotations. Just think of them as little sticky notes you put on your code that tell the framework exactly how to behave.
And check this out, this is the beautiful part. With just one little line of code, one of those @tags, you're basically telling the entire framework, hey, when a URL looks like this, send it right here to this piece of code. It's so clean, it's declarative, and it saves you from writing pages and pages of setup code.
Okay, so the request made it past the front door. Awesome. Now we're diving deeper into what you could call the brain of the application. This is where all the real business logic happens. So how do all the different components in here talk to each other?
So now we've got another challenge on our hands. An application isn't just one big blob of code, right? It's made of all these different pieces that have to work together. How do we connect them without creating a total mess, a tangled web of dependencies? We need some kind of manager that knows how to create these components and hand them out exactly when they're needed.
And that's where CDI, or Contexts and Dependency Injection, comes into play. If Jakarta REST was the front door, CDI is the glue that holds the whole house together. It's this powerful service that automatically manages the lifecycle of all your components. When one part of your code needs another, CDI is the one that figures out how to provide, or inject, it.
And this is where it feels like magic, seriously. Instead of you having to manually create and manage all these objects, you just declare what you need with this @inject annotation. It's like saying, hey CDI, I need one of these, and boom, the container just finds the right thing and hands it to you automatically. It just leads to way cleaner, way more maintainable code.
All right, so our app can handle requests, it can run business logic, but it can't remember anything. Any serious application needs a memory, a way to store and retrieve data. So let's talk databases.
And if you're a developer, you know this pain. It's a classic headache. In our code, we love working with nice, clean Java objects. But databases, they think in tables, rows, and columns, and you talk to them with SQL. So how do we bridge that gap without spending all our time writing hundreds of tedious insert and select statements?
Well, the Jakarta EE answer is JPA, or Jakarta Persistence. And honestly, the best way to think about JPA is as a professional translator. You get to speak in your native Java objects, and JPA takes care of all the messy, complex SQL translation behind the scenes to save, update, and fetch those objects from the database for you.
And you're probably sensing a pattern here, right? Just like before, the magic kicks off with a super simple annotation. You take a plain old Java class, you add @entity to it, and you've just told JPA, hey, this class, it's a database table. From there, JPA can figure out how to map all the fields in your class to columns in that table. It's so powerful.
But okay, storing data is just part of the story, because applications are alive, they change, they evolve. And that means your database structure, your tables and columns, has to evolve too. And that's where this quote from D-Zone really hits home. Using database migration tools is absolutely vital for modern apps. You have to be able to control your database changes just like you control your code changes.
And that brings us to the big players in this space, Flyway and Liquibase. They kind of have different personalities. Flyway is all about keeping things simple. You write your database changes in plain SQL. It's straightforward and powerful. Liquibase, on the other hand, is all about flexibility. It lets you define your changes in abstract formats, like XML or YAML. This means you can write one migration script and run it on different databases, like PostgreSQL and MySQL, without changing it. Both of them, though, plug really nicely into the whole Java ecosystem.
Okay, so we've followed that single request all the way from the web, through the application's brain, and down into its memory in the database. Now let's pull back and look at the big picture. Why would you choose this platform in the first place? What's the real advantage?
So, what's the bottom line? Well, first off, it's standardization. Jakarta EE is a specification, which means your code isn't locked into one vendor's product. It's portable. Second, the container handles all the tough stuff for you: transactions, security, concurrency. You don't have to build that plumbing from scratch. And that directly leads to the third point. You, the developer, get to be way more productive. You focus on solving actual business problems, not reinventing the wheel. And finally, it all comes together in this rich, cohesive model where all the parts are designed to work together beautifully.
And all of this leaves us with a really interesting final thought. You know, in today's world of microservices and cloud-native everything, you might wonder if a big, comprehensive standard like Jakarta EE is still relevant. But maybe, just maybe, it's more relevant than ever. It gives us a common language, a stable, battle-tested foundation to build the next generation of really robust applications on. It's definitely something to think about.